Hello all. Good morning, good afternoon, and good evening. This is Laxmikanth Mukund Sethu Kumar, an Executive Director at JP Morgan Chase Bank. This is for Conf42 Quantum Computing 2025 event, and the topic is bridging classical and quantum computing. Let's start with a quote. Quantum computing is not going to be a replacement for the classical computing. It's rather it's a transformation of classical to quantum computing and how we use it. So the kind of fundamentals is your mindset should shift, considering it as a coexistence instead of as a competition between the classical and quantum computing. The reality is the shift is real, and there are already major players like AWS, IBM, and Azure have quantum computing areas. Like example as the AWS Bracket, IBM Quantum, and Azure Quantum. And there are almost more than 100 plus quantum related patents filed in 2023 alone. And there are many startups and enterprises R&Ds prototyping hybrid workflows between the classical and the quantum computing. It started as a theory and it has become a lab, and now it's all cloud native APIs available for quantum computing. And these are all the proof points. And let's think about what's between the classical and the quantum and what are the emerging needs. The classical system is well known for its performance optimization, security, and reliability. The emerging needs while we are shipping or running in a hybrid model of classical and quantum would be quantum for the combinatorial optimization, machine learning acceleration, and molecular simulation. We need to have an interface to have the classical event talk to the quantum using the event-driven pipelines. And to start with, for an enterprise architect to know how and what needs to be done, here are some of the fundamentals that we need to think about. So the quantum 101 for classical architectures. The quantum core principles is about qubits, superposition, entanglement, and interference. And we need to understand the classical computing works on binary, which are zeros or one, but the quantum can have a state which is simultaneously either a zero and a one. So it's also more as a probabilistic state than as a binary state. So our thinking thought process should change of considering a state as either or as a binary instead as a probabilistic state. Next, what are all the challenges we have in this journey, starting from the classical to the quantum computing? So the current state of the quantum computing doesn't fit into our existing DevOps stacks. Major missing pieces are the job orchestration, state isolation for quantum workloads, and also the latency tolerance. So these are the problems that needs to be solved, but I'm sure in the near future it will be eventually solved and it will be in a very mature state. The next thing, let's talk about how a hybrid architecture for a quantum and a classical computing works together. So your application layer, the first tier could be all microservices with APIs. And then your middle tier or your orchestration layer could be for quantum job routers and queues. And the lower backend services could be classical computing and also quantum computing or a combination of both of them together. So overall, still the problem for quantum not fitting into the DevOps stack is there, but still these models are workable and there are prototypes and solutions being done based on these models. Next, the major design patterns, what we need to consider for our quantum computing area would be quantum as a service. Just like we have infrastructure as a service, software as a service, and everything as a service, quantum as a service is another design pattern that's predominantly being considered. And also we have to consider all the quantum triggers from the classical event queues like a Kafka. So when we club between the classical and the quantum, the communication medium could be a PubSub model where the classical can be producing an event to which a quantum needs to react based on the event that the classical has produced. And we also need to be predominantly working on the serverless quantum microservices, just like it's a Lambda, what we have. A Lambda can trigger AWS bracket. Next, the middleware integration layer, what we talked about earlier. The main responsibilities for those areas will be on the session management, job queuing, and the error retries, result normalization. So the strategy would be to solve this problem area to decouple the quantum logic from the orchestration logic. So we should not combine them as a single computation. Instead, it should be two different segregation of duty. And major tools, as I mentioned earlier, that could be used would be the AWS Bracket SDK, the Quiskit runtime, SIT gRPC and bridges, and many more are there in the queue. Now, with cloud nativity being the forerunner at this point of time, the cloud native abstraction for the quantum area could be in the areas of like containers running quantum SDKs for local simulations, or you can have a K8 jobs runners which can orchestrate your quantum flows and your serverless options. As I mentioned earlier, the AWS Lambda along with the bracket trigger and the DevOps quantum job linting CI/CD for quantum kernels in the future. So these are the cloud native abstraction that needs to be considered. And the more important thing of whether it is a classical or a quantum would be on the security, interoperability, and observability. And security, as mentioned in the slide, you can see the authentication across classical and quantum boundary should be taken care very well. It should be a zero trust model. The interoperability between the classical and the quantum would be the protocol standardizations like the QAR and the open QASM. Vendor neutral interfaces are very important, so the interoperability will be much easier. And the observability will be for telemetry for the quantum jobs and the integration with the Prometheus and Open Telemetry, just like how we have integrated them with the classical computing today. Then here is a practical roadmap for the enterprises to consider. First, the step one would be identifying the quantumable problems, like example, like scheduling, machine learning model tuning, and more. And the step two, after once we have identified, is to build a dev sandbox for the emulators for the quantum. And once the emulators are all ready, the third step would be to integrate with job orchestration and message buses. So this message bus, as mentioned earlier, will be the one which will be a hybrid communication between the classical and the quantum. And the step four would be to come to the pilot state where we have a hybrid service non-critical in a non-critical path and gradually promotion towards the production workflows as a step five, and that will be iterate. Next, future. Now, once we have all of this in happening in our hybrid model, the end state or the future state to have a non-destructive strategy would be to have how we integrate modularly or adapt layers to existing system and at the same time minimize the risk using the polyglot SDK and simulators as well as mature hybrid CI/CD pipelines. So the goal would be to experiment without rewriting the stack. We should be maturing into the stage where this hybrid model will work well for any problem statement we want to solve. Further to that, the next 5 years or even less is not about the quantum dominating, it's about quantum augmentation along with our classical. It's not a replacement, as I said at the beginning. It is going to be in conjunction with our classical, the quantum also will be working and solving the problem much better than just the classical solving or just the quantum solving. And with that, we come to an end. And thank you for the opportunity. Thank you all.